All right, so our goal and objective for this video is to be able to apply the 4 types of transformations. Now, we've already gone through transformations with linear equations, quadratics, some cubic functions we've gone through. More recently, we just finished going over it with radical equations and functions, and you'll see it's exactly the same for exponential functions and equations as it was for those as well. So the 4 types of transformations that we have is whether or not it is going to be stretched or compressed, whether or not we're going to be reflecting it, and any translations that we might have. And remember, translations are when we're moving left or moving right, or when we're moving up or when we're moving down, right? So those are the 4 types of transformations that we're going to discuss. Now, when we're going to talk about these transformations, we're going to use y is equal to a times bx, where the b raised to the x power is considered our parent function. And as I'm going to show you in a second, the parent function for this one actually changes depending on what our base is, what our base b is. But this number a that we have out front, this letter a, whatever is being multiplied to it will help us determine whether or not it is stretching or compressing, and possibly whether or not we're reflecting the graph as well. All right, so first thing I'm going to do is just show you a few different parent functions that we might have. All right, so when we have these functions, this first one that we're going to graph, y is equal to 2 to the x power, this is considered the parent function for when our base is 2. Right, now when we graph y is equal to 0.5x, this is our parent function for when our base is 1/2 or 0.5. And then when we graph y is equal 5 to the x power, same thing. This is our parent function for this particular problem. So it's not going to be what we've done in the past where it's one parent function we're talking about. The parent function actually changes depending on what base we have, right? So we're always going to be referring back to the parent function for that particular base. All right, so now let's just go through all the different transformations that we have. So remember, our parent function is just whatever y is equal b to the x power. So it can change depending on what that base is. It could be y is equal to 2x like we did, y is equal to 1/2 x like we did, or y is equal to 5 raised to the x power like we did. Like all these are considered parent functions for this particular base. Right now, when we have a number a that's being multiplied to this, if the absolute value of a is greater than 1, then that means it is stretching out. If the absolute value of a is between 0 and 1, that means it is compressing or shrinking. And remember, we're always looking at the positive values of a, because anytime a is negative, it automatically means that it is being reflected. And in this case, it's being reflected about the x-axis, right? So that's why in these ones we always focus on the positive a, because once it's negative, that just tells us it's being reflected. And then we still need to focus on the positive value to see, is it shrinking or is it stretching? And then same thing as we've done before. If it's being done to the x, so in this case, it is x minus h is in parentheses, that's telling us whether or not we're moving left or right, and we're moving opposite of the sign. So if it's b raised to the x minus 4, this means we're moving right 4 units. All right, and then the same thing as before, anything that's being added or subtracted at the end, that tells us whether or not we're moving vertically or if we're going up or down, and we follow the signs. All right, so now let's just go through a few examples. First one, how does the graph y is equal to negative 1/3 times 3 raised to the x power compared to the parent function? So all we're going to do is list the different types of transformations. So one, the negative sign that we have, so I'll put it in yellow here. The negative sign just tells us it's being reflected, and this is being reflected about the x-axis. All right, so this one is being reflected. This 1/3 is the a, the absolute value of a. So next we'll look at our second one that we're going to compare, which we'll highlight in green so you know that we're comparing that number. This is telling us whether or not we're stretching or compressing. And since the absolute value of 1/3 or negative 1/3 is greater than 0 and less than 1, this is telling us that it is going to be a shrink or a compression. Right? Nothing is being added or subtracted to this problem at all, so there's no vertical or horizontal shifts. All right, just a few more questions that we're going to go through. This one, to determine what's happening to its parent function. So in this case, there's only one thing that's being done, and it's being subtracted by 4. So remember, since it's included with that x value, that means that we're moving horizontally, and we need to move opposite the sign. So this is just being shifted or moving right 4 units. So it's being translated about our graph. So it's just moving right 4 units. So if this was our original parent function, then the other one is just going to be moved 4 units to the right. All right, and then the last one that we're going to do, and then this video is over, so it's a fairly short video, is now we have multiple things. So first thing, we'll list 1, 2, and that's it. There's 2 things. So the first thing that we're going to talk about is what this number is happening. So we're going to highlight that A. So anything that's being multiplied. So remember, our parent function here is simply this 0.25x. So since this is being multiplied to it, that tells us whether or not we're going to be stretched or compressed. And since the absolute value of 5 is greater than 1, this means it is going to be a stretch. So we know that this graph is being stretched out. This plus 5 is being done at the very end. It's not being included with that x. So that tells us whether or not we're moving vertically or horizontally. And since it's not being, it tells us whether or not we're moving vertically. So since it's not being included, we're moving up or down. We go with the sign, so this means we're moving up 5 units. All right, and that's it for this video, just being able to identify transformations and translations that are happening, something that we've already done before with different functions and equations.